lesson 1. So solving system of linear to quadratic. So that means a linear function, a line, so just a single x, and a quadratic with an x squared. Okay, and just so you know what I'm talking about, here's the picture. You got a parabola with a line. Okay, so that's what we're talking about. Linear quadratic system of equations is a system which one of the equations is linear. Quadratic is the other one, obviously. Determine the value of x and y that satisfy both equations. Okay. So in calculus class, in order to determine the shaded area of the region between the parabola of x squared and x plus 6, it's first necessary to determine the points of intersection. That's what we're focusing on. So we're not figuring out the area. You actually do that in calc. It's kind of neat. You cut it into slices, but that's for a later date. But we have to figure out these points because that's how you figure out the slices. So we're kind of doing the first part. We'll go ahead and just do it on our calculator start. Okay, so if we go to our calculator start, we're going to put x squared in box 1, or y1, and x plus 6 in y2. So we go clear, let's go x squared, and x plus 6. Not sure if my window's good, we'll see. Nope, need a little bigger. So my window probably should go, my max should go to maybe 15. There we go. Okay, so we're finding intersection points. You guys have done intersect probably 10 times this semester, I feel like. But second trace, number 5. Okay, arrow over the left side of the parabola, hit enter. The line's close to it, hit enter, enter. First answer, -2, 4. -2, 4 is one of the solutions of that quadratic to linear equation. It is both the answers. Okay, it is a point that satisfies. Okay, and then find the second one here quickly. Second trace, number 5. We go ahead and move over again. Just go on the other side of the parabola, the upswing, and hit enter. Jumps up, hits enter, enter. Oh, it went back to the other one, sorry. I gotta go closer. All right, let's get over there farther. There we go. Enter, enter, enter. There we go. 3, 9 is your other solution. Okay. All right. So that's it for that, for the graphing part. So we got those solutions, so we can write those down. Okay, so we got -2, 4, 3, 9. It says use the method of substitution or the method of elimination to algebraically solve. So that means is use your math 10 skills to solve this system. So what you need to know is you know that y equals x squared, and you know that y equals x plus 6. So what you can do is, that's what they both y equals, so you can set these equal to each other. Does that make sense? They're both equal to y, so you can set those x's equal to each other and solve. So it's going to be this. X squared equals x plus 6. That's essentially substitution. Okay? That's why we sub that y into there. And so now we solve. We're good with this. We minus the x minus the 6. You see that we have a quadratic that we can factor to -3 and plus 2. And it's not a coincidence. That means my two x values, 3, we had 3. -2, we had -2. That's not a coincidence. Okay, so we have those. How do we find the y's? You plug it into either equation. So what I mean is, if you put 3 squared, what's 3 squared? 9. -2 squared, 4. Or, right here, what's 3 plus 6? 9. -2 plus 6? 4. Okay, so it doesn't matter which one you plug it into. So you get the same exact thing. And you've done that process in Math 10. Okay, and we honestly, we just verified. So we don't have to do this part again because we just verified by plugging it in to get y. Okay. So if you plug in 3 and 3, you'll get 9 and 9. If you plug in -2 and -2, you'll get 4 and 4. Okay. All right, so the solutions to these linear to quadratic system is x is 3 and 9, or -2 and 4, or the point 3, 9 and -2, 4. Okay. All right, so now we're going to talk about what to expect and how like the discriminant can kind of help us. Okay. So note that in a graphical method, both a linear and quadratic equation need to be written in the form of y equals. Because obviously, if we're doing graphically, you need y to be by itself so you can plug it in, right? So when you're doing those, they have to be in y equals. But if you're doing algebraic, it doesn't have to be. You could do elimination or other stuff. So it's up to you. So what it says here is x squared minus x minus 12 is shown on the grid. So that's that big grid there to your right. Obviously, I'm a little bit blown up here. If we go down a little bit, that's a little too much. Okay, so that's the graph here. And so you see you got zeros at -3 and 4, because that's what the factors are. It says sketch a line points of the intersections on the grid. So it wants us to do y equals 3x. So we're going to draw y equals 3x. So y equals 3x just goes through the origin. It's up 3 over 1. Up 3 over 1. Down 3 over 1. So it's roughly doing this here. Oh, that's not very good. Let's try that again. All right. So this right here is the intersection point. And if we go the other way, it's right there. So we kind of have it coming through here. It's a little better. Okay, so you can see the two intersection points. So just from graphing it, you see your intersection point is, looks like it's 518. Or is it 618? 618. Okay, so 618 is an intersection point for my drawing. And -2, -6 is the intersections there. Okay, so again, how do I draw 3x? 3x just means a line with a y-intercept of 0 that goes up 3 over 1 as a slope every time. So that's how I got that if you weren't sure. Okay, and then if we go to B, it wants us to do a different one. It wants to try the 3x minus 16 line. So 3x minus 16, so that now we do have y-intercept. It's down here at minus 16. It's all the way down here. Okay, so if I go down here, I go up 3 over 1, up 3 over 1, up 3, wait, let's see here. So that's kind of what it looks like. And so it barely misses here. I know this one looks like it's hitting, but this is actually the real intersection. So this line comes through, and it kind of hits at one spot. We call that tangent. So you want to make a note here. Tangent is a line that goes through a graph at one location. Tangent to, that means one intersection. Okay. And so we're going to go, I'm just doing the graphs first, and we'll do the work second. So we are supposed to do it algebraically as well. Okay, and then we do 3x minus 24. Okay, 3x minus 24, you'll see that it never intersects. So if I'm down here at minus 24, up 3 over 1, up 3 over 1, up 3 over 1, it just stays below that parabola the whole time and never intersects it. So there's three options, just like we had before in terms of solutions for quadratics. We had 1, 2, and none. Okay, so we have the same situation. Tangent's the second one I drew. This is the 0 solution, and the first one's 2 solutions. So let's look at it algebraically now. So just under here, let's talk about this one algebraically, y. Well, let's go ahead and put y is equal. So let's write it as 3x equals x squared minus x minus 12. So we're just writing it substitution for the y's again and solving. So we subtracted 3x over. We get x squared minus 4x minus 12, which is x minus 6, x plus 2. That's why those points I wrote down were -6 and -2. So 6 is my x value, -2 is my x value. Yeah. Right here. That's the line we drew. Yep, that's all right. Good question. Okay, and so then how we find the y is we just plug it into either. It doesn't matter which one we plug into. So 6 times 3 is 18. So that means it was 618. Negative 2 times 3 is negative 6. Again, if you put it here, it would be the same exact answer. Okay, if I put it here, look, I'll do 1. 6 squared is 36, minus 6, minus 12. 36 minus 6 is 30, minus 12 is 18. Okay, so that's what happens with that one algebraically. Okay, any questions so far? Okay, so check this one out. The 3x minus 16. We're expecting how many answers from our drawing? 1. So let's see how's that going to happen. So I get 3x minus 16 equals x squared minus x minus 12. Now, let's see if we can answer this before we even do it. What happens with our quadratic formula, our discriminant, when we got one solution? What? Right, 2 the same. So what would you think might happen here? 2 the same what, though? What's the... You're saying it, yeah. Factors. Yeah. Well, you guys kind of were saying it. You're beating around the bush, but we're having the same factors. Okay? Because we're going to get like an x minus 4 because it's being repeated. That means one solution, just like a discriminant, right? So let's see if that happens here. So I'll move the 3x over. So negative 1 minus 3 is negative 4. Add the 16 gives me a negative 4. And sure enough, the factors are, yeah, positive 4, thanks. Add the 16. It's x minus 2, x minus 2. So 2 is repeated. So it's one solution at 2, negative 10. Okay. Tangent means once, like a balance. Tangent 2 means it hits it at one spot. Tangent 2. And we talk about that in trig as well. Tangent 2. Yep.
So is to negative 10 like the graph?
Right. For this picture that I drew, when I drew it, 2 negative 10 was it. So 3x negative 16, when I went up 3 over 1, up 3 over 1, yeah, so see right here, that's 2 negative 10. That's where it hits one spot. So it hits it, and then it starts to go away from it again. 2 negative 10. Okay, and then the last one we're talking about, the no solution, the one that misses it completely, and what that looks like algebraically. So that's on the next page here. So then same thing, we're going to do 3x minus 24 equals the x squared minus x minus 12. So 0 equals x squared minus 4x plus 12. There's no factors of 12 that are both positive that get you negative 4. So that means we have to use quadratic formula. Okay, so if we go to use the quadratic formula and we start to set it up, we get 4 plus or minus, negative 4 squared is 16, minus 4 times 1 times 12, all over 2 times 1, which is 2. We don't have to go very far because we know what's happened. The middle, the discriminant or the part in the radical tells us what's going to happen. We have 16 minus 48 here. So that means we have, excuse me, that means we have negative 32. That's a problem. That's a no solution. And so there is no solution for this system. So knowing your discriminant, knowing your solving can still help you solve these type of systems. Okay? All right, so we just got to fill out these notes and we're done with this one, then we're going to go to quadratic to quadratic. Okay, if the graph of a linear equation and the graph of a quadratic equation accept 2 points, the linear equation system has 2 solutions. If the graph of a linear equation and the graph of the quadratic equation intersect at 1 point, the linear quadratic system has 1 solution. And if they completely miss, they have no solutions. Okay. And, okay, so yeah, we're to this last piece here. Okay. So this part says, in the process of solving a linear quadratic system of equation, we end up solving another quadratic equation. The discriminant of the resulting quadratic equation can be used to determine how many answers to expect. So complete the following. If the resulting quadratic equation has 2 distinct roots, the discriminant would be what? So what? Right, good. Positive, you remember. Positive in a linear system has 2 solutions, good. If the resulting quadratic equation has 2 equal roots, the discriminant is 0. Nice. 1 solution. And the resulting quadratic equation has no real roots, the discriminant is negative, and no solutions or 0 solutions. Okay? And again, this is kind of what I was telling Justin, repeating, when we say a line is tangent to a parabola if there's only one point of intersection. So if you want to underline that, remember tangent. People tend to forget that vocab word. So, okay, we'll stop there.